What if I told you, a simple math game could level up your brain and your developer portfolio? Welcome back to BugNoJutsu. Introducing Math Quiz App, a fast, fun, and fully functional web app built from scratch. Whether you're a math lover looking for a challenge, or a web developer searching for your next portfolio project, this app has it all. Dynamic quiz logic, real-time scoring, clean UI, responsive design. And yes, it's built with HTML, CSS, JavaScript. Stick around, because in this video I'll walk you through how it works and how you can build something like this yourself. Let's go. This HTML document forms the foundational structure for a math quiz web application that allows users to practice simple arithmetic problems. At the top, the HTML file sets up the document type and specifies the language as English. Inside the section, it includes meta tags to define the character encoding as UTF-8 and ensure the layout is responsive across various devices using the viewport setting. The page title is set as Math Quiz App, which appears in the browser's title bar or tab. Additionally, a link is made to an external CSS stylesheet named style.css, which will control the visual design aspects such as fonts, colors, spacing, alignment, and responsiveness. This separation of structure, HTML, and styling, CSS, is a good practice in modern web development. Within the main interface of the quiz is placed inside a container which helps in grouping and centering the content on the screen. The first visible element is a heading that displays the title Math Quiz, clearly communicating the purpose of the app to the user. Directly beneath the heading is another with a class called Problem. This section displays the math problem dynamically. It includes 3 elements, one each for the first number, number 1, the mathematical operator, and the second number, number 2. The operator displayed could be one of the basic arithmetic operations, addition, subtraction, multiplication, or division, written as plus, minus, multiplied by, or divided by. These spans act as placeholders that will be updated dynamically by JavaScript when a new question is generated. An equal sign is displayed after the problem to indicate the user needs to provide a solution, and an input field of type number is presented with the placeholder your answer to accept numeric input from the user. This field allows the user to type in their answer for the current math question. Beneath the input field, there are 2 buttons that control the interactivity of the app. The first button, labeled Check, has an ID of checkBTN and is designed to validate whether the user's answer is correct when clicked. The second button, Next Question, identified by NextBTN, generates a new math problem when clicked, allowing users to continue practicing. Between these buttons lies a with the ID result, which is reserved for displaying feedback such as correct, or oops, try again, based on the user's submitted answer. At the very end of the body section, the HTML links to an external JavaScript file, script.js, using a tag. This script file holds the core logic of the application, including the generation of random math problems, the display of appropriate operators like plus, minus, multiplied by, or divided by, answer validation, and updating the result feedback. Overall, the HTML structure is clean, semantic, and well organized, making it an excellent foundation for both beginner-friendly learning and developer portfolio showcasing. This CSS block is known as a universal reset and plays a critical role in ensuring consistency across different browsers. It targets all HTML elements on the page using the *** selector, which means apply the following styles to every single element, regardless of type. Let's break down what it does. The first property, margin, 0, removes the default margin, the space outside the element, that browsers typically apply to elements like headings, paragraphs, or sections. Similarly, padding, 0, removes the default padding, the space inside the element, between its content and border. These 2 properties help eliminate unpredictable spacing, giving you full control over the layout and spacing in your design. This is especially important in responsive design or pixel-perfect layouts. The third line, box sizing, border box, is perhaps the most crucial for layout behavior. By default, HTML elements use the content box model, where the width and height you set for an element apply only to the content area, and any padding or border gets added on top of that, increasing the actual size of the element. This can lead to confusing or broken layouts. Setting box sizing, border box, changes this behavior. Now, the total width and height of the element include content plus padding plus border. This makes it much easier to manage dimensions because the size of the element stays consistent no matter how much padding or border you add. Applying it globally ensures a more predictable and manageable layout throughout your app. So in short, this 3-line reset makes the design process cleaner, more consistent, and less prone to unexpected spacing issues caused by browser defaults. This CSS block styles the entire of the web page, which serves as the base container for all visible content. The first line sets the font family, specifying a prioritized list of fonts: Sego UI, Tahoma, Geneva, Verdana, and a generic sans serif. This means the browser will try to use Sego UI first, and if it's not available, it will fall back to the next font in the list. This ensures consistent and modern typography across different systems. Next, the background property uses a linear gradient, starting at a 135-degree angle. It blends two soft, pleasing colors, #E0C3FC, a light purple, and #ADC5FC, a soft sky blue, to give the background a smooth and visually appealing gradient effect that feels lively and modern. Then comes the flexbox layout. By setting display, flex, the body becomes a flexible container. The justify content, center, centers its children horizontally, and align items, centers them vertically, ensuring that the main container, in this case, the doc container div with the quiz UI, is placed exactly in the center of the screen, both top to bottom and left to right. The min height, 100 VH, ensures that the body is at least as tall as the full height of the visible browser window, 100% of the viewport height, which is essential for vertical centering to work correctly even on smaller screens. Finally, the animation property adds a subtle entrance effect. It uses a keyframe animation named fade-in, lasting 1 second, with an ease-in timing function, which means the animation will start slowly and finish at a normal speed. This creates a smooth visual experience as the page loads. Instead of content just popping in, it gently fades into view, improving the overall aesthetic and professionalism of the app. This block defines a CSS animation named fade-in, using the @keyframes rule, which allows you to create smooth transitions between sets of styles over time. The animation consists of 2 main stages: a from state, the starting point of the animation, and a to state, the final appearance. In the from block, the opacity is set to 0, which means the element will be completely invisible when the animation starts. Additionally, transform, scale, 0.98, slightly shrinks the element to 98% of its original size, giving the impression that it's just about to pop into place. This subtle scale-down effect adds a touch of motion depth. It's not just fading in, but also gently expanding. In the to block, the opacity is changed to 1, making the element fully visible, and the transform property is reset to scale, 1, which restores the element to its normal size. When this animation is applied to an element, as seen in your earlier body styles, it creates a smooth and polished entrance effect where the content fades in while gently growing from a slightly smaller size. The combination of fading and scaling enhances the user experience by making the page feel more dynamic, interactive, and modern, rather than static and abrupt. The doc container class styles the central quiz box that holds the math problem and user interaction elements. First, the background is set to white, which ensures the content stands out cleanly against the colorful gradient background of the page, improving both readability and visual contrast. The padding, 40px 30px, creates space inside the container, 40 pixels vertically, top and bottom, and 30 pixels horizontally, left and right. This padding gives the content breathing room and prevents it from touching the edges of the box. The border radius, 20px, adds rounded corners with a smooth curve of 20 pixels, giving the box a soft, modern, and user-friendly appearance rather than harsh, sharp edges. Next, the box shadow property applies a subtle drop shadow, 010px 25px raba, 0, 0, 0, 0.15. This means the shadow is offset by 10 pixels downward, blurred by 25 pixels, and slightly transparent with a black color at 15% opacity. The effect is a glowing or elevated look that makes the container appear to float above the background, adding depth and visual hierarchy. The text align, center, ensures all the text and inline elements inside the container are horizontally centered, which enhances symmetry and improves readability, especially important for a quiz interface. The width, 90%, makes the container responsive, allowing it to shrink or expand based on the screen size, up to a max width of 420px, which caps its size on larger screens to maintain a neat and compact layout. Finally, the animation, slide up one's ease out, applies a smooth entrance animation named slide up, which plays over 1 second. The ease out timing function causes the animation to start quickly and finish slowly, making the container feel like it gently rises into place from below the screen when the page loads. Combined, these styles create a professional, mobile-friendly UI box that looks clean, centered, and engaging to users right from the first interaction. The @keyframe slide-up block defines a custom CSS animation named slide-up, which controls how an element animates into view. It consists of 2 stages, the from state, the starting point of the animation, and the to state, the final result after the animation completes. In the from block, the element is visually shifted downward by 20 pixels using transform, translate y, 20px. This makes it appear as though the element is slightly below its final position on the page. At the same time, opacity, 0, makes the element fully transparent, meaning it's invisible at the start of the animation. These 2 properties combined create the effect of the element being slightly hidden and lower than where it should end up. In the to block, transform, translate y, 0, resets the element back to its original vertical position, and opacity, 1, makes it fully visible. When this animation is applied, as it is in the .container class, it creates a smooth visual effect where the container slides up into place while fading in. This CSS block is used to style the main heading of the app, which is represented by the tag. The first property, margin bottom, 20px, adds a 20-pixel space below the heading, ensuring that there is a clean and comfortable gap between the heading and the content that follows, like the math problem section. Next, font size, 32px, increases the size of the heading text to make it bold, prominent, and clearly distinguishable from the rest of the text on the page. This helps in drawing the user's attention to the app title, in this case, Math Quiz. The next part of the styling is particularly eye-catching and creative. The background property is set to a linear gradient, moving from left to right, and blending 2 vibrant colors, a rich purple, #6A11CB, and a strong blue, #2575FC. However, instead of applying this gradient to a background block, the code uses a clever trick to apply the gradient inside the text itself. This is achieved using WebKit background clip, text, a property that clips the background gradient to the shape of the text characters. By default, background images or gradients are clipped to the elements box, but with this property, the gradient follows the outline of the text. The next line, WebKit text fill color, transparent, makes the actual fill of the text completely transparent, so the only thing visible is the gradient behind the text, giving the text a gradient-colored look. This combination of gradient background clipping and transparent text fill creates a stylish, modern, and visually engaging heading. It adds personality and uniqueness to your app, making it look more like a polished product rather than a basic project. This technique is often seen in high-quality UI designs and helps give your project a professional touch. The .problem class styles the section that displays the arithmetic question the user has to solve. The font size, 26px, increases the size of the text inside this section, including the numbers and the operator, making it easy to read and visually distinct. The margin, 25px0, adds vertical spacing above and below the .problem block, helping separate it from the heading and the buttons for better layout structure. Additionally, the animation, fade-in 0.6s ease in out, applies a short fade-in effect, giving a smooth visual transition when the math question appears on screen, enhancing the user experience by adding a sense of motion and interactivity. The next block targets the field inside the .problem section using the selector .problem input. The width, 120px, gives the input box a fixed width, large enough to type short numerical answers without taking up too much space. The padding, 10px, ensures there is space inside the input field, making it feel roomy and comfortable to use. The font size, 20px, ensures the typed text is clearly visible. The border, 2px solid #CCC, gives the input field a light gray border for subtle visibility, while the border radius, 8px, gives the corners a gentle roundness, making it more user-friendly and modern. The margin left, 10px, separates the input from the equals sign symbol so it doesn't stick too close, and the transition, 0.3 SEs, allows any changes, like on focus, to animate smoothly instead of happening instantly. Finally, the .problem input focus selector defines how the input field behaves when a user clicks into it or begins typing. Border color, #6A11CB, changes the border to a vivid purple, matching the app's color theme and giving immediate visual feedback to the user. The outline, none, removes the browser's default focus outline, which often looks inconsistent or outdated. Lastly, transform, scale, 1.03, slightly enlarges the input field by 3%, giving a subtle zoom-in effect that makes the interaction feel dynamic and responsive. Together, these styles make the problems section not only functional but also visually engaging and user-friendly, especially on both desktop and mobile devices. This CSS block applies to all elements across the page, giving them a consistent, polished, and interactive look. The background, #6A11CB, sets the button's background color to a rich purple shade, which is visually striking and aligned with the app's gradient color scheme. The color, white, makes the text inside the button stand out clearly against the dark background, ensuring good contrast and readability. The border, none, removes the browser's default button border, giving the button a cleaner, modern appearance. Next, the padding, 12px-24px, adds internal spacing, 12 pixels vertically and 24 pixels horizontally, making the button larger and easier to click or tap, which improves accessibility and user experience. The margin, 10px-5px, adds spacing outside the button, 10 pixels vertically and 5 pixels horizontally, so that when multiple buttons, like check and next question, appear, they don't touch each other or surrounding elements. The border radius, 8px, rounds the corners of the button, giving it a smooth, user-friendly shape instead of a harsh rectangular box. The font size, 16px, ensures the text size is legible and well-balanced within the button size. The cursor, pointer, changes the cursor to a pointing hand when a user hovers over the button, signaling that it's clickable. Finally, the transition property, background 0.3 SEs, transform 0.2 S, adds smooth animation effects when the button is hovered or clicked. For example, if the background color or scale changes, like growing slightly, it will happen smoothly instead of suddenly, giving a professional, responsive feel to every interaction. This thoughtful styling makes your buttons not only attractive but also intuitive and pleasant to use. This CSS block targets the hover state of all elements, meaning the styles inside it will only take effect when a user moves their mouse pointer over a button. The background, #2575FC, changes the button's background color to a bright and vibrant shade of blue when hovered. This immediate color shift provides visual feedback, reassuring the user that the button is interactive and ready to be clicked. It also adds a nice contrast to the default purple background, making the button feel dynamic and alive. Next, the transform, translate y-2px, slightly lifts the button upward by 2 pixels on the y-axis. This subtle elevation gives a tactile feel, as if the button is reacting to being touched or pressed, enhancing the perception of depth and interactivity. This kind of movement mimics physical behavior, making the UI feel more responsive and natural. Finally, the box shadow, 04px-12px RABA, 0, 0, 0, 0.1, adds a soft shadow behind the lifted button. It's offset by 4 pixels vertically and blurred over 12 pixels, with a very light black color at 10% opacity. This shadow reinforces the lifted effect by creating a sense of depth, almost like the button is floating just above the page surface. When combined with the transition effects defined earlier, these hover styles smoothly animate in, making every button interaction feel intentional and visually engaging, just like you'd expect from a professionally designed interface. This CSS block targets the element with the ID result, which is used to display feedback to the user, such as whether their answer to a math question was correct or incorrect. The font size, 20px, makes the result text large enough to be easily seen and understood without overwhelming the layout. It strikes a good balance between visibility and subtlety, making sure the feedback is clear while maintaining the overall clean look of the app. The margin top, 20px, creates space above the result text, ensuring that it doesn't sit too closely under the button elements. This spacing helps visually separate the result feedback from other content, making it easier for users to focus on the message that appears after they check their answer. The final line, transition, all 0.4s ease in out, is a powerful styling feature that controls how any visual changes to this element happen, particularly properties like color, size, or visibility. When a style change is triggered, such as changing text color or opacity after an answer is submitted, this transition ensures that the change occurs smoothly over 0.4 seconds. The ease in out timing function makes the transition start slowly, speed up in the middle, and slow down again at the end, resulting in a polished, fluid animation. This improves the user experience by preventing abrupt or jarring visual shifts, making the feedback feel more natural and well integrated into the app interface. These two CSS classes, .correct and .wrong, are used to visually differentiate the feedback shown to the user based on whether their answer is right or wrong. The .correct class applies styling to indicate a correct answer. It sets the color property to #28A745, which is a vibrant shade of green, widely recognized as a positive or success color in user interfaces. When this class is applied, likely to the hashtag result element, it also triggers an animation called pop that lasts 0.3 seconds with an ease in out timing function. This means the animation starts slow, speeds up, and then slows down again, making it feel smooth and subtle. The pop animation, presumably defined elsewhere in your code, likely causes the result message to gently scale or bounce in place, emphasizing that the user got the answer right in a friendly and satisfying way. On the other hand, the .wrong class is used when the user provides an incorrect answer. It changes the text color to #DC3545, a strong red tone that is commonly associated with errors or alerts. Just like .correct, this class also triggers an animation, but instead of pop, it uses shake. The shake animation, also defined in your keyframes, probably causes the text to wiggle or jitter slightly, simulating the feeling of something being rejected or marked incorrect. This feedback is immediate and intuitive. This code defines two CSS animations named pop and shake, each using the @keyframes rule to specify how elements should visually change over time. The pop animation is designed to create a scaling effect. It starts with the element at its normal size, scale, 1, briefly enlarges it to 1.2 times its size at 10%, and then shrinks it back to normal. This effect is often used to highlight something, like a button press or a correct answer, drawing the user's attention in a fun and engaging way. The shake animation, on the other hand, is focused on horizontal motion. It moves the element left and right at specific percentages of the animation timeline, starting and ending at its original position. At 25%, it shifts left by 5 pixels, at 50%, it moves right by 5 pixels, and at 75%, it shakes slightly left by 3 pixels. This creates a visual vibration or jitter effect that is commonly used to signal something went wrong, like incorrect input. These animations enhance user experience by adding immediate and intuitive visual feedback, making the interface feel more responsive and lively. This block of JavaScript code is responsible for selecting and storing references to specific HTML elements from the web page using the document.getElementById method. This method allows JavaScript to directly access and manipulate DOM, document object model, elements based on their unique ID attribute. By assigning these elements to constant variables using the const keyword, the script ensures these references remain unchanged and accessible throughout the rest of the code. First, const number1l equals document.getElementById, number1, retrieves the HTML element with the ID number1, which is likely used to display the first number in a math equation or problem. Similarly, const number2l equals document.getElementById, number2, gets the second number element from the DOM. These two elements together represent the numerical parts of the problem displayed on the screen. Next, const operator l equals document.getElementById, operator, grabs the element that displays the operator symbol between the two numbers. This tells the user what kind of arithmetic operation they are expected to perform. Following that, const answer input equals document.getElementById, answer, stores a reference to the input box where the user types in their calculated answer. This is a crucial interactive component, as it gathers user input that will later be validated by the program. Then, const resultl equals document.getElementById, result, accesses the element responsible for displaying the feedback, whether the answer is correct or incorrect. This gives the user real-time response after their submission. Finally, const checkBTN equals document.getElementById, checkBTN, and const nextBTN equals document.getElementById, nextBTN, refer to the two buttons in the interface. The checkBTN is used to trigger the logic that validates the user's answer, while the nextBTN loads a new question once the current one is completed. The line let correct answer equals 0 declares a variable to store the correct result of the current math problem. It uses let so the value can change with each new question. Initially set to 0, it gets updated based on the generated numbers and operator. The line function generateQuestion defines a new JavaScript function named generateQuestion. This function acts as a container for logic that will generate a new random math question each time it is called. It begins the function block using curly braces, and all the logic for creating and displaying the question will be placed inside this block. Functions like this help keep code organized and reusable, especially when you need to perform the same set of tasks, like creating a question, multiple times. This segment of the script is responsible for dynamically generating a random math question by selecting two numbers and an arithmetic operator. The logic begins with defining a set of common mathematical operators, such as addition, subtraction, multiplication, division, and modulus, which are stored in a list. These operators act as the core actions to be performed between two numbers, forming the basis of the math problem. To ensure variety, the script then generates two random whole numbers. It does this by using a technique that first creates a decimal number between 0 and 1, then scales it up to a range from 0 to 99, rounds it down to the nearest whole number, and finally adds 1. This process ensures that the generated numbers fall within the 1 to 100 range, avoiding 0 to keep all operations meaningful, especially in cases like division or modulus where 0 could cause errors or confusion. Once the two numbers are ready, the script randomly selects one of the operators from the previously defined list. It does this by generating a random index based on the total number of operators and picking the operator at that position. The outcome is a fully randomized math question, such as 27 plus 68 or 45 modulo 9, which can then be displayed to the user for solving. This entire mechanism keeps the practice interactive and unpredictable, making it useful for learning or testing arithmetic skills. This portion of the script is responsible for updating the user interface with the newly generated math question and preparing the page for a fresh user input. Once the random numbers and operator are created, the script begins by displaying them in their respective elements on the web page. The first number, number 1, is shown in the designated HTML element, likely a OR, meant to display the first operand. Similarly, the second number, number 2, and the selected operator, like plus or multiply, are inserted into their corresponding placeholders in the UI. This allows users to clearly view the entire question, such as 43 by 6. After displaying the new question, the script clears any previous user input by resetting the input field where the user types their answer. This is important to ensure that the new question starts with a clean slate and doesn't carry over values from the last problem. In addition, any previous feedback message, whether it was correct or incorrect, is also cleared out from the result area. This includes both the message text and any CSS classes, such as correct or wrong, that might have been applied for styling purposes. By resetting these, the interface remains visually neutral and ready to give fresh feedback based on the user's next answer, keeping the experience clear and responsive. Once a math question is generated, comprising two numbers and an operator like plus, minus, multiplication, division, or modulo, the script uses a switch control structure to determine which mathematical operation should be applied. The switch evaluates the operator and then executes the corresponding block of code that matches it. If the operator is addition, the script adds the two numbers and stores the result in a variable meant to hold the correct answer. Similarly, for subtraction, it subtracts the second number from the first. If the operator is multiplication, the two numbers are multiplied. For division, the script divides the first number by the second and then uses the tofixed 2 method to round the result to 2 decimal places for better readability and precision. Since tofixed returns a string, it's converted back to a number using parsefloat to ensure proper numeric comparison later. Lastly, if the operator is the modulus, it calculates the remainder when the first number is divided by the second. This logic ensures that regardless of which operator is chosen, the corresponding operation is performed correctly and the answer is stored in a variable ready to be used for answer validation when the user submits their response. An event listener that waits for the user to click the check button. When the button is clicked, the code inside the event handler function runs. At that moment, the user's input, which they typed into the answer field, is captured and converted from a string to a number using a parsing method that handles decimal values accurately. This conversion is important because the input field stores data as text, and a numerical comparison is needed to evaluate whether the user's answer is correct. By doing this, the system can proceed to validate the answer against the previously calculated correct result. Validating the user's input to ensure it is a number. When the user clicks the check button, the program first checks if the input they entered is not a number using the isNaN function. This function returns true if the input is not a number, which helps prevent invalid or empty inputs from being processed further. If this check fails, meaning the input is invalid, a message saying "Please enter a number" is displayed in the result area to guide the user. Additionally, the result elements class is set to wrong, which likely applies a red color or a shake animation to indicate an error visually. Finally, the return statement ensures that the rest of the function doesn't execute, stopping the program until the user provides a valid numeric input. This project serves as an engaging platform to practice and strengthen basic arithmetic skills in an interactive way. By presenting random math questions with real-time feedback, it helps users develop accuracy and confidence in solving problems. The immediate validation of answers fosters quick learning and reinforces concepts effectively. It incorporates visual animations like pop and shake to make the experience lively, which keeps users motivated and focused. The project also familiarizes beginners with essential web development skills like HTML structure, CSS styling, and JavaScript functionality. Users get hands-on experience with DOM manipulation, event handling, and logic implementation. It's an ideal tool for students, teachers, and coding learners to apply both educational and technical concepts. As a mini-game or learning tool, it adds fun to foundational learning without overwhelming the user. It can be expanded for more complex topics, making it a scalable and reusable project. Overall, it bridges the gap between entertainment and education while empowering users with essential skills. Whether the user's answer is correct based on the displayed arithmetic operation. It uses a ternary operator, which is a shorthand conditional expression, to handle two different comparison approaches depending on the operator. If the operator is division, /, the comparison is done using a tolerance check. Instead of checking for strict equality, it uses math.abs, user answer, correct answer, less than 0.01, which means it checks whether the absolute difference between the user's answer and the correct answer is less than 0.01. This small tolerance is important because division often results in floating point numbers, which can have small rounding errors. So this approach ensures that answers like 4.33 and 4.32999999 are considered effectively equal. If the operator is anything other than division, the user's answer is directly compared to the correct answer using strict equality, since those operations result in whole numbers or values that can be compared exactly. The final result of this expression is stored in the isCorrect constant, which will be a Boolean, true or false, indicating whether the user's input matches the expected result. This part of the code is responsible for handling how feedback is shown to the user after submitting an answer, managing the next button functionality, and ensuring that a new question is displayed when the page loads. First, the if is correct condition checks whether the user's input matches the correct answer. If the answer is correct, a success message saying correct is displayed inside the result L element, and its class is updated to correct, which likely changes the styling to indicate success, like green text or a highlight. On the other hand, if the user's answer is incorrect, the else block executes. It shows a message wrong, followed by the actual correct answer. The class is changed to wrong, which probably styles the message differently, like red text, to show that the answer was incorrect. After handling the result display, an event listener is added to the next button, Next btn. When the user clicks this button, it calls the generateQuestion function, which resets the values and generates a new math question, giving the user a fresh problem to solve. Lastly, outside of all event listeners, the generateQuestion function is called immediately so that when the page is first loaded, a math question is automatically displayed to the user without needing to click anything. This ensures the interface is interactive and ready right from the start. And that's a wrap, warriors of the code. If you've made it this far, give yourself a pat on the back. You're not just learning, you're evolving. Every single line of code you write, every bug you squash, every logic you untangle, it's one step closer to the developer you dream to be. Whether you're here solving LeetCode challenges, learning new frameworks, or just exploring the beauty of logic, remember, you're building your future, one keystroke at a time. If you found this video helpful, give it a thumbs up and let me know in the comments which part made your brain spark the most. Got stuck somewhere? Ask away, this is a community, not just a channel. And hey, don't forget to subscribe to BugNoJutsu because here, we don't just code, we master the ninja art of debugging, problem solving, and leveling up together. I've got tons of epic coding content, anime-themed problem breakdowns, roadmap tips, and secret techniques coming your way. Oh, and if you're feeling stuck or demotivated, remember this, even the greatest devs were once beginners. Stay consistent, stay curious, and stay you. Until next time, may your syntax never error out, and keep building. Keep grinding. This is BugNoJutsu, signing off, but always watching the code. Peace, power, and semicolons. See you in the next one, legends.